Okay, welcome to the next video for Unit 7 over single replacement reactions. Okay, so the first thing that we need to go over is what is a single replacement reaction. A single replacement reaction is where you have one element that replaces another in a compound. And so I have an example right here. You have A, which is alone, and that is added to, usually it's a solution of B and X. And what you notice is that A and B will swap places. And that is basically the gist of a single replacement reaction, but you need to actually know why this happens, and you're going to have to predict if this is going to happen or not. And so what you have, the reason that this happens is that A is something, usually it's a metal, that is more reactive than B, which is less reactive. And so it's going to take the place of B, and it's basically going to steal X away from B. And usually X is a negatively charged compound. It's some sort of anion. A and B are usually metals, and they are positively charged. So the cations will switch places because one is more reactive than the other. I like to use an analogy of A is usually some sort of single guy, and B and X are a couple. And so A is more reactive or better looking, and he's going to steal the girl away from the other guy. And so the analogy that I always use to explain these is that the better looking guy, which is our metal, gets the girl, which is an anion. Now that's not true in life, so don't take that to heart, but it's just an analogy that we use to explain these reactions. So naturally, the next question you're going to be asking is, how do you know which metal is more reactive in the reaction? So what you're going to be using is called an activity series, and you actually already have this because this is on the back of your reactions guide that you made in class. And so it has metals listed out, starting with the most reactive at the very top, so that would be lithium, and ending with the least at the very bottom, which would be gold. So you're going to use this to determine if the single metal, if the one that's alone, if it's more reactive, it's going to steal the place of the less reactive metal. So we're going to be referring to this when we work out the next examples. So now let's work out some examples of single replacement reactions. First, you need to recognize this is a single replacement reaction because you have an element that is by itself, and it's added to a solution that is a compound of a metal and a nonmetal. So the question is aluminum going to replace zinc because it is more reactive? And so what you have to do is you have to look at your activity series chart, and when we pull this up, we notice that aluminum is up higher than zinc is on this chart, and so that does mean that aluminum is going to take the place of zinc. So what we're going to do is we're going to finish this equation by showing what's actually going to happen. So if zinc is going to get replaced by aluminum, that means that zinc is going to be written out by itself alone on the product side. And since it's a metal, it's going to be a solid. And now that aluminum is with chloride, we have to rewrite a new formula. And so aluminum and chlorine are going to get bonded together, and usually that's going to remain as an aqueous solution. Aluminum is from group number 13, and so it has a +3 charge. Chlorine is in group 17, has a -1. So you have to remember that these ionic compounds that you are creating, you have to write the charges above them and crisscross their charges. Now once you've done this, you now need to go back and make sure that this is balanced. As you can see, the chlorines are not balanced. You have 2 on the reactant side and 3 on the product side. So this is that situation where you're going to make them equal up to 6. So I'm going to add a 3 here and a 2 here. So now I've got 6 on both sides. But now we've screwed up our metals. So I'm going to fix the zinc and fix the aluminum, and now I have a completed single replacement reaction. Okay, next one we have magnesium, solid magnesium that's added to a solution of cobalt nitrate. And so, and I've already noticed there's an error in this equation. There should be a 2 here. And so the question is magnesium more reactive than cobalt? Is it going to replace it? So again, we're going to pull up your activity series chart, and we see that magnesium is right here, and cobalt is lower. So magnesium is going to take the place of cobalt, and so now we need to write what this reaction is going to be completed to. So if cobalt is going to get replaced, we're going to write cobalt by itself on the product side, and it's a metal, so it's going to stay as a solid. And then magnesium is going to bond with nitrate. So magnesium and NO3. Now that's not the right formula because we need to remember to cross the charges. Magnesium is in group 2, it's got a +2. Nitrate, you should memorize, has a -1. So we're going to have to bring that 2 down. And the couples usually stay as aqueous solutions. So then we have to go back through this and make sure that it is balanced. So if we notice, our nitrates are balanced, our magnesiums are balanced, and our cobalts are balanced. So you don't have to do any extra work on this one. Okay, last example, we have solid gold that's added to hydrochloric acid. So in this situation, we have gold as our metal, and even though hydrogen is not a metal, remember hydrogen acts like a metal. So the question is gold going to replace hydrogen? And so again, we're going to pull that up on our activity series chart. If you notice, gold is actually at the very, very bottom of your activity series chart. So gold is actually never going to get the girl. It's never going to replace the metal because hydrogen is the most reactive and it's already with the anion. And so what you're going to end up doing, these are going to be your favorite reactions, because if the single metal is not good enough to replace the other one, then that means you get to just write no reaction. And you can write that in shorthand if you want to and just write NR. The reason we get to write that is because gold is not more reactive than hydrogen, and so it's just going to remain the same. Okay, for this video, I do want you to write a summary. Go ahead and answer the 3 questions that we worked out in this video. Define what a single replacement reaction is. Discuss how you have to use the activity series to know about a metal's reactivity. And then talk about one example. How do you actually predict a reaction? Talk about how you have to look at that activity series and take the place of one metal. And discuss how you can have a reaction that actually occurs and a reaction that doesn't occur.